want to talk to you about a strategy for factoring trinomials. This strategy we're going to use is trial and error. There are actually a number of strategies that you can use for factoring trinomials. This is the one that I actually use. It's not just the one that I show students, it's the one that I generally use when I'm factoring trinomials myself. Now, to do this, we need to keep in mind that factoring a trinomial is really undoing a product of binomials. So let me refresh your memory on how to multiply binomials, and then we'll factor a bunch of trinomials. So let's go. We'll start with this problem. Multiply 3x minus 7 times 2x plus 9. And remember, to multiply binomials together, you can use the acronym FOIL, which means you multiply the first two terms together first. So we'll get 6x squared. Then we multiply the outside terms together and we'll get 27x. We multiply the inside terms together and we get negative 14x. And we multiply the last terms together and we get negative 63. And as is often the case, these two terms in the middle are like terms, so we'll combine those. So we get 6x squared plus 13x minus 63. Now here's the part that I want to point out. Notice that this first term right here came from the product of the first two terms. And the last term here came from the product of the last two terms. Now it's the middle where we have to do a little bit more work. It comes from a couple of terms, the outside terms and the inside terms combined. So, keeping all of that in mind, let's reverse that process when we factor. Here's the problem. It will be 3x squared minus 10x plus 8. Of course, when we're factoring, we always look for our common factor first. Notice there is no common factor besides 1. But I'm factoring a trinomial and I have the expectation that it's going to factor into two binomials. So I set up my two sets of parentheses. Now I saw in the multiplication problem that this first term came from the product of these two first terms. So I'm going to break up 3x squared into 3x and x. Now the product of these last two terms needs to be 8. And my choices are 1 times 8 or 2 times 4. And notice, because we're going to get a positive 8, I need to have both the signs be the same, either both plus or both minus. Well, I see that I need a negative 10x in the middle. That means they both better be minus, so I'm going to put those in. But now here comes the trial and error part. I have to determine whether it should be a 1 and an 8 and a 1, a 2 and a 4, or a 4 and a 2 in these last terms. Let's just start with 1 and 8. Does it work? Well, remember, the goal is to have the middle term be negative 10x. And in order for that middle term to be negative 10x, the product of the outside terms and the product of the inside terms added together better give us negative 10x. Notice here it gives us negative 24x and negative 1x, so that is not it. So let's switch the 1 and the 8 and make it an 8 and a 1. So let me erase. And now we're going to try 8 and 1. 8 here, 1 here. I didn't erase this part. Whoops. Okay, now let's try. On the outside, we get a negative 3x now, And on the inside, we get negative 8x. That's negative 11x. So close, but it is not negative 10x. So I see that 1 and 8 does not work. So now I move to 2 and 4. So let me do my erasing. And let's try 2 and 4 in that order. If it doesn't work, I'll try 4 and 2. So 2 and 4. Both the signs, remember, needed to be negative. So if we FOIL this out, we get negative 12x and negative 2x. Ooh, that gives us negative 14x. It's very tempting to just change the sign. I think, well, if I just change this minus to a plus, I'll then get a positive 2x, and that gives me negative 10x in the middle. But then I wouldn't get the positive 8 at the end. I have already determined that the signs both need to be minus. So with a minus on both of those places, the 2 and the 4 does not work. So we're going to switch it and make it 4 and 2. Let's try 4 and 2. And now when I multiply, let me see what I get. Erase that. On the inside, I get, let me grab my pen. I have a negative 4x, and on the outside, I have a negative 6x. That does add up to negative 10x, so this one is done. Now, sometimes people talk about this taking a while. It did take me a few minutes to get through this problem because I was talking it through. But with practice, you do get much faster at determining what the correct values will be. Let's look at another one. This example will be to factor completely 2x squared plus 13x plus 15. Do look for our common factor. There isn't one besides 1, so our expectation is that we will factor into 2 binomials. So let's set up our parentheses. 2x squared will split up into 2x and x. I'm looking at the sign over here. It's a positive, so I know the signs here and here have to match. And because I have a positive 13, I know they both need to be positive. So let me put that in. So for 15, my choices are 1 times 15 or 3 times 5. And you can start with whatever looks good to you. I'll just start with my 1 and 15. Notice on the outside, I would have a 30x. And on the inside, I would have a 1x. So that is not it. Let's move on. And let's try the next one. The next thing I will do is switch the 1 and 15 and make it 15 and 1. On the outside, I get a 2x. On the inside, I have a 15x. Ooh, that looks almost right. But remember, they are both positive, so they don't add up to 13. So in fact, we see that 1 and 15 did not work. Let's move on to 3 and 5. Let me erase. And we'll pop 3 and 5 in. We'll try 3 here and 5 here. And on the outside, we have a 10x. Whoops. On the outside, we have a 10x. On the inside, we have a 3x. That does add up to 13x, so this one is done. Let's do another one that looks very similar. Notice the only difference is the last term on this one is a negative 15 instead of a positive 15. But let's see how it affects our results. Let's set up our 2 sets of parentheses. We'll start with 2x and x again. Our choices are 1 and 15 or 3 and 5. Because I have a negative here, I know one sign needs to be plus and one sign needs to be minus. I don't know which is which. I will put those signs in later. I'm going to keep that in mind, though. So let's try 1 and 15. Notice on the outside that gives us a 30x, and on the inside a 1x. So there's no way a 30x and a 1x would give me a 13. I don't care what the signs are. So let's switch them. Let's put a 15 here and a 1 here. Now let's try. On the outside we'd have a 2x, and on the inside we'd have a 15x. Hey, that's promising. Let me write it out so you see what I mean. 15x and a 2x, as long as we can make the signs work. Remember I said at the beginning of this one, one's plus and one's minus. We need a positive 15x and a negative 2x in order for the sum to be 13. So that means I'm going to put a plus on the 15, a minus on the 1, and I will get the 13x in the middle, and my 15 times negative 1 is equal to negative 15. So this one is factored. So look how different the factors were. This one versus this one. Just that last sign being different gave us a completely different result. Let's do another problem. This one looks like 9x squared plus 7x minus 2. Do look for a common factor first. It's easy to overlook that, especially when you've done a few problems where there wasn't a common factor. There still is not one besides a 1, so I move on. It's a trinomial, so I'm going to expect it to factor into 2 binomials. Now this time I have a 9x squared up front. So I have to decide whether I want to try a 3x and a 3x or a 9x and a 1x. So using my trial and error strategy, pick one. If it doesn't work, we'll move on to the 9x. We'll move on to the other one. So I'm going to try 3x and 3x first. Notice this sign is negative here, so I know one sign is plus and one sign is minus. I usually put the differing signs in at the end. So let's try for 2. 1 times 2. It's kind of nice. We don't have much to try there. 1 and a 2. That gives us on the outside a 6x and on the inside a 3x. I don't care what you do with the signs. You can't get a 7x from that. And notice on this one, I'm not going to switch the 1 and the 2 because the leading terms right here were both the same. If these are the same, then switching the 1 and the 2 doesn't do anything. Doesn't change your result. So we see that 3x and 3x does not work. So we move on to 9x and 1x. So let me erase. And we'll pop in the 9x and the 1x. And already I have the 1 and the 2 in, so we might as well try it in the order in which it's presented right here. So on the outside, we would have an 18x, and on the inside, a 1x. 18x and 1x, again, won't do in any way give us that 7x. So that doesn't work. So let's switch our 1 and 2 around, and we'll make it 2 and 1. So this time on the outside, I have a 9x, and on the inside, I have a 2x. Ooh, that one might work, 9x and 2x. I definitely need the plus on the 9 and the minus on the 2. So I will put a minus right here and a plus right here. And this one's done. Let's look at this next example. It is 9x squared minus 3x minus 2. Note again that there is no common factor besides 1. So I set up my parentheses. Again, the choices for the first terms are 3x and 3x or 9x and 1x. I'll start with 3x and 3x this time. Again, I have a negative 2 as my constant. So I'm going to try 1 and 2, and one of them will need to be negative and one positive. So let's pop it in. Pop those in, and we get 6x on the outside and a 3x on the inside. Oh, that will work if our 6 is negative and our 3 is positive. That means we're going to put the plus on the 1 and the minus on the 2. And this one's done. Sometimes you're lucky and you can get the right answer very quickly. Let's look at this next example. It is x squared plus 3x minus 28. There's no common factor besides 1, so we set up our parentheses. This one is particularly nice because this leading coefficient is 1. If we have this coefficient as a 1, we know we can just split it up into x and x if it's going to factor at all. So the possibilities for 28 are 1 times 28, 2 times 14, 4 times 7. And with practice, you start to identify the numbers that seem like they'll work, and you don't necessarily have to write the list as I did. Do you see that 4 and 7 look good for getting that 3 in the middle? If I put a 4 here and a 7 here, notice on the outside, you'll have a 7x, and on the inside, we'll have a 4x. As long as the 7 is positive and the 4 is negative, that will add up to 3. Well, to 3x. And notice we do need a 1 positive and 1 negative because this is a negative 28. So I'm going to put in the plus right here on the 7 and the minus on the 4. Let's look at this next example. It is x squared minus 15x plus 36. Just pause this video and try it on your own. Did you get it? Often when people are factoring, they try to stare at the problem and hope that the numbers pop into their mind that will be correct. Now, I love it when that happens. If there aren't very many possibilities, that definitely can happen. But sometimes the numbers don't just pop into your head. On this one, they may or may not have, but suppose they didn't. Then you definitely want to write a systematic list so you don't overlook anything. 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go into it, or 6 times 6. Do notice that because this is positive, we need the signs here to match, either both plus or both minus. But because of that negative 15x, we want them both to be negative. So let me pop that in. So what numbers will give us that 15 or that negative 15x in the middle? Do you see that it's the 3 and the 12? Notice when you FOIL this out, the negative 12x plus the negative 3x gives you that negative 15x. Let's move on. Our next one looks like this, 3x squared plus 15x minus 18. It is very common for people to overlook the common factor. In fact, if I had to name the one thing within factoring that causes more problems, it's overlooking that. So let's take out the common factor of 3, and then we have x squared plus 5x minus 6. Let's keep going. We have a trinomial there, and we're going to see if it will factor into 2 binomials. My x squared will get broken up into x and x. 6 can be broken up into 1 times 6 or 2 times 3. I'll try 1 and 6 first. If it doesn't work, I'll try 2 and 3. Notice that this sign right here is negative, so that means I have 1 plus and 1 minus. Well, on the outside, I would have a negative 6x. On the inside, I have a 1x. And if I put a plus on the 6 and a minus on the 1, I will get the 5x that I need in the middle. And we have it factored. Let me show you what would have happened if we had overlooked the common factor. So you just didn't see it and you set up your parentheses. So when you try to factor, you'd put a 3x and an x in. Notice we have more possibilities for the product for 18. Now we would be talking about 1 times 18 or 2 times 9 or 3 times 6. Again, one of those numbers would have to be negative. But notice I have more numbers to roll through. Eventually, you'll probably find that you get something like this. 3x minus 3 times x plus 6. And somebody's very happy if you FOIL that out. You would, in fact, get 3x squared plus 15x minus 18. But here's the problem. Notice the directions up here said factor completely. This factor right here is not completely factored. You could continue right here. When you see there's a common factor of 3, bring it out, and you can still get the correct answer. But let me just mention this. I would take out the common factor first for 2 reasons. One, notice that the problem was easier to factor right here versus right here. There weren't as many possibilities to try. It was an easier trinomial to work with. The second reason I would just get in the habit of factoring out the greatest common factor at the beginning, like I did here, is I have found that people who forget to take out the common factor at the beginning, they forget to look for it at the end. So while I might get a lot of people to get to this factorization, many times people forget to continue. So just make it a habit. Take out the common factor first every time. What if we had a problem that looked like this? You'll notice there is no common factor besides 1, so we don't have to take anything out. But you see that it looks kind of funny? It seems backwards to me. I don't like the quadratic term to be last if I have a linear term up front. So I would rewrite it as negative x squared minus 9x plus 36. But I still don't like it because I don't like that leading term to have a negative. Take out a negative 1. I mean factor out a negative 1. So I would have in parentheses x squared plus 9x minus 36. And I'm just happier factoring that trinomial. I can leave the negative 1 out front, and in fact, you don't have to write the 1 part, just the negative. Now I'm expecting it to factor into 2 binomials. I set up my x and x. 36, do the numbers just leap into your head, then you can write them down? If not, here's the list of possibilities. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go into it, and 6 times 6. So those are the possibilities. And let's see, what would give us 9? Do you see the 3 and the 12 look good? If we pop in the 3 and the 12, we would have a 12x on the outside and a 3x on the inside. Notice I need a positive 9 in the middle. So I'm going to put the plus on the 12 and the minus on the 3. And this problem is complete. Let me just mention that there is nothing wrong with actually factoring the trinomial in this order. I just don't want to, so I did it this way. Let's look at the next example. It is x squared plus 7x plus 15. You'll note there is no common factor besides 1, but I will expect it to factor into 2 binomials if it's factorable. I split up my x squared into x and x. Everything is positive, so I'm going to put the pluses in. Now the possibilities are 1 times 15 or 3 times 5. If we pop in the 1 and the 15, notice we would get a 16x in the middle. So that doesn't work. If we pop in the 3 and 5, we would get an 8x in the middle. So that doesn't work. But we've exhausted all of the possibilities. So in fact, the original problem is not factorable, and you would just write prime. Our next example is to factor x squared minus 12xy plus 20y squared. Notice there's no common factor besides 1. It's still a trinomial. I just have that extra variable floating around, but let's see how that will affect what we do. I'm setting up my parentheses. I'm still breaking up the x squared into x times x. Because this sign right here is a positive, I know the signs in the binomials need to be both plus or both minus. Because of this negative here, I know that means they are both minus. So let's put those in. Now here's where things are just a little bit different. Instead of 1 times 20 and 2 times 10 and 4 times 5 as possibilities, I know I need a 20y squared. That means I need to try 1y times 20y, or 2y times 10y, or 4y times 5y. Do you see which one looks good for getting that negative 12xy in the middle? How about this one right here? We'll pop in the 2y and the 10y. And notice, if you FOIL this out, you get a negative 10xy and a negative 2xy. So we do get the negative 12xy that we need in the middle. For these last few examples, I want to show you something that can speed up the process in some problems. Let's look at 2x squared plus 17x plus 36. It is important for this idea to make note that there is no common factor. If you don't pay attention to that, what I'm going to say won't work at all. But there is no common factor besides 1. So let's set up our parentheses, and we will have 2x and x for the first terms. Everything is positive, so I'll just put the pluses in. So now I'm looking at the possibilities for 36. They are 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go into it, and we have 6 times 6. So initially it looks like we have lots of things to try. 1 and 36, 36 and 1, 2 and 18, 18 and 2, 3 and 12, 12 and 3, 4 and 9, 9 and 4, or 6 and 6. Whew! And that's one thing that bothers people about trial and error method sometimes. But if we use this additional strategy, we can eliminate some possibilities. In fact, I can eliminate 2 and 18 and 6 and 6 without even trying. And here's why. Suppose 2 and 18 had been correct. We know it's not, but suppose that it had been. Notice that in this binomial, I have a common factor of 2. So in my next step, I would have to take out a common factor of 2. But remember up here at the beginning, we said there was no common factor besides 1. And if there is no common factor at the beginning, there can be no common factor later. So when I'm looking at what numbers to substitute in, I'm not going to put in any number with this 2x that would create a common factor situation. So right here, no 2 and no 18 is possible because that creates a common factor. Notice I eliminated it. 6 is not possible, so I eliminated it as well. Furthermore, as I roll through these possibilities, 1 and 36, 3 and 12, or 4 and 9, I will make sure that I don't put an even number here. So if I try 1 and 36, I will just put the 1 here and the 36 here. And of quickly you see that that doesn't work. So we move on to 3 and 12. Again, the 3 would need to go in the first binomial and the 12 in the second if it's going to work. Notice we'd get a 24x and a 3x. That doesn't add up to 17x. And that brings me to the last possibility, which is 4 and 9. But I cannot put the 4 right here. I have to put the 9 here in the first spot and the 4 here. So when we FOIL this out, we get an 8x on the outside, a 9x on the inside, and that adds up to 17x, and it's done. Now, it took me a little bit longer than normal because I was talking it through with you, but let's keep this in mind for our next example. We're going to factor 5x squared minus 52x plus 20. Look for a common factor. Do you see that we don't have any to take out? I set up my parentheses. I have 5x and x. Because this sign is positive, I know that the signs better be a match, either both plus or both minus. So I better, in this case, put in minus on both because of that negative 52x. So the possibilities for 20 are 1 times 20, 2 times 10, or 4 times 5. Now here's where the no common factor comes into play. I am not going to put any number here that creates a common factor with this. That means no multiple of 5. So 5 cannot go here, 10 cannot go here, and 20 cannot go here. So I can put the 1 here and the 20 here, but that doesn't give me the negative 52 that I need. So let's try the 2 and 10. So we'll put the 2 here and the 2 here and the 10 here. And on the outside, we'll have a negative 50x, and on the inside, we get a negative 2x. And hey, that's it. We don't need to try anything more. Let's factor one more problem. Here it is. 4x squared plus 5x minus 6. Notice there is no common factor to take out. So here we go. We'll set up our 2 sets of parentheses. I see I have a 4x squared, so I have to decide whether to try 2x and 2x or 4x and 1x. I'll just start with 2x and 2x. If it doesn't work, I'll move on to 4x and 1x. The possibilities for 6 are 1 times 6 and 2 times 3. But here's what I want you to see. We can immediately eliminate both as a possibility. Because notice if we put in the 1 and the 6, we would have created a common factor. And there is no common factor in the original problem. If we had put in the 2 and the 3, same idea, we would have created a common factor right here. So with 2x and 2x, there isn't anything to try. So as quickly as that, we know that 2x and 2x cannot be it. So I'm going to try 4x and 1x. And now I'm back to the 1 and 6 and 2 and 3. Well, let me write that out. 1 times 6 and 2 times 3. But again, I will not put in any even number right here because it would create a common factor situation. So let's try 1 and 6. Notice on the outside I would get 24x. On the inside I would get 1x. There's no way I could get a 5 from that. So I will erase and try 2 and 3. But again, I can't put the 2 in the first set of parentheses. I will put the 3 there. So I would have an 8x on the outside and a 3x on the inside. Ooh, that could work. Notice, here's the 8x. Here's a 3x. We do need 1 plus and 1 minus because of that negative 6. So I need the plus on the 8x and the minus on the 3x to get a positive 5x. So that means I'm putting the minus on the 3 and the plus on the 2. and this one is factored.